Hi, Johan. How are you doing?
I'm fine. I'm fine. How are you?
Even better, I think, because you are cold.
Yeah, I have a slight cold, but hopefully it will be okay. Yeah.
Yeah, I'm doing Java, so cold is not a problem. There's no virus, nothing. Everything's secure.
Great. Me too.
Great.
Me too.
You too. Okay. Um, so you created an interesting library. It's called Occurrent,
Yeah.
and the question is why.
Yeah, that's a very good question because and maybe I should clarify. This is a library that contains a lot of pieces for building event-sourced applications.
Mhm.
Yeah, there is also like framework kind of features. But yeah, so I started mainly. I have a friend that is also very interested in event sourcing, and yeah, we have kind of gone back and forth. His name is Per Öqvist, by the way. We've gone back and forth over the years, talking about event sourcing and domain-driven design and all those kind of things. And he has had his own like framework for .NET.
Mhm.
And we were, yeah, kind of discussing that back and forth. And I was kind of teasing him, couldn't you do this in like simpler ways? You don't need all these concepts and things like that. And I was like, just like teasing him a bit, like saying that, you could use higher order functions here instead, and then you don't have to implement all of these like things as distinct concepts. And then, yeah, he said like, maybe you should implement something yourself. And I said, yeah, maybe I should. And that's the origin of it. So yeah, I've had a lot of ideas over the years, and yeah, I tried to make something out of it in the current library.
What's interesting, this Occurrent is based on CloudEvents, and I just
Yes.
look it up. On 2020 on this podcast, we had already a discussion with SAP about CloudEvents. And why
Aha.
that? Because back then I had to do something in the cloud and with events, and I wanted to use the standard way. And cloud events were the thing to do. And they were very simple back then. This is very early cloud event days, and they actually evolved. What's really good? They are part of CNCF right now, which is amazing because back then it was not clear whether they will take off actually. And so so before we start to talk about cloud events, do you have use cases? So you just built, to the Occurrent just to show that Java is way better than .NET, or are there
No.
real use cases, or
Yeah, I think I mean that was one of the motivations. Not to say that's better than .NET, but to try to like yeah, really like think through some of my ideas that I had floating around in my head.
Mhm.
But no, also that I mean the use case in my mind would be like to like can I build something like myself that kind of works like in production for systems that I typically work with
Mhm.
that has like a good test story. As you know, I'm kind of into to testing a lot, so it should
Mhm.
be like easy to test. And also I wanted to experiment with having a way to allow you to write event source the domain models in a way that you decide, and not that a particular framework forces you to go in one way or the other.
Mhm.
And that's why I also chose to go with the library approach first. And also, yeah, to allow event sourcing to be gradually introduced into yeah your regular projects.
Mhm.
Because many times I think that event sourcing can feel quite overwhelming, and that's not to say that Occurrent is not can't be. I mean, there are a lot of modules in Occurrent, but you don't have to use all of them.
Mhm.
It's very like flexible in that sense. But yeah, so it's essentially something that I wanted for myself, something that I could really trust in a sense. And that yeah should work in production for the use cases that I typically encounter. And this is not like the most extreme scale. I wanted something that was pragmatic, something that was easy to use, and maybe challenging some of the assumptions that I think that I understand, or I hope that I understand them, but I decided to loosen some of these things up a bit to make it easier to use for the kind of applications that I typically build. Yeah.
And what kind of concrete examples or use cases do you have in mind?
Yeah, so what I have in mind here is that there is like this, how should you say, that you should never, it is kind of an anti-pattern to say that you should query the event store, for example, and I understand why. I mean, it's not the same thing, but event sourcing is often like talked about in the same how do you say it, in the same similar sentence as CQRS, like command query responsibility segregation. And that, also for maybe scalability reasons and stuff like that, you shouldn't do queries on your event store. But some things can be, in my experience, much more easy if you do allow some queries to the event store. For example, you can have consistent reads for certain use cases, or just answer like, for example, get like a log over a user, regardless of the user has done different things in different aggregates. And here it's a bit technical, but you can assign one of the cloud attributes called subject to represent the user. And if that's consistent, I can index the user in the database, and I can query, the user, and I get all the things that the user have done. So that's one example. And also things that can be quite tricky in normal event sourcing. And there are ways around that now with something called dynamic consistency boundary. But for example, like an email, maybe you have a hard invariant. Now you could argue whether this is really like a really hard invariant or not in this case. Like an email, for example, that one user should only have one unique email address. If you want to guarantee a unique email address per person, one way to do it is actually to use unique constraints in the database. And so I wanted to allow stuff like that. In event sourcing, that can be a bit tricky to implement these kind of things if you really want it to be consistent.
Examples of that, what you are doing is in my project was always somehow Kafka related. So this was the origin idea of Kafka. By the way, I only know, I think, 2 projects which use Kafka the right way. All the others are shifting byte arrays around and without any additional, semantics. But the idea is, and a concrete example, the coolest one was, before the pandemic, so there were tractors and they are emitting events. And what we had to do is actually this is actually interesting with the query state, because what they were doing, they're moving around and they were submitting data to a central database. And the problem was scalability indeed, because we had to query the database, and this was one database for writing and reading, and this caused some problems. But with event sourcing, we considered the tractor as event source, and they emitted events, all the devices around the tractor plus the tractor emitted events. And the cool story is then we could use Kafka with Kafka streams, and we had something like the Java 25 gatherers, so we could in real time actually calculate some statistics, and there were no issues with performance at all. So this was one thing. Recently was what I also did similar to or event sourcing is state transitions. If you provision an application, there are also obvious state transitions and you would like to subscribe to it. So this was one of things. So, and your library, usually if you have event sourcing, you have a kind of a domain object, and you already mentioned user or email, and something happens to the object. So instead of persisting the final state of the object, we are capturing every state change, state transition in the object as an event, right? And the event is just point of time. No one cares whether someone listens or not. It's just an event, and the event are ordered and persisted. So this is what we're talking about. And now the question is, what happens with the events? And the events can be stored in a central database, what you're saying right now, which I'm absolutely fine with it. And and you said it is considered as an anti-pattern, which I wouldn't care. I mean, if the database is fast enough, and we're not always on Netflix scale, so it means if it does the job in my enterprise environment, I wouldn't care.
No, yeah, and yeah, I agree with that, obviously. But I just want to emphasize here that, I mean, like event sourcing, it's so, I mean, if you read about event sourcing, you can get quite like confused because it can seem like event sourcing is something that is really complex. You usually see a lot of boxes and difficult diagrams and a lot of strange words. But what event sourcing, I mean, it is really simple. I mean, it's just that instead of you storing like your state, and you update your state like a row in a database. So instead of having like a row with different columns, you instead just have a list of events. Like this is what you store, and you always, and this is the crucial thing, you need to, when you make decisions like on this like object that you're interacting with, you need to base your decisions on the previous events and a command like what you want to achieve, but you always base the decision on the events that you have stored in your database. But that's sorry, that's event sourcing, and it has well, in a strict sense, it doesn't have anything to do with CQRS, but it's often like talked in the same way or in the same breath.
The CQRS
it's not the same thing.
From my perspective, is just the idea that you can have you can use for reading and writing different channels, different approaches, and this is basically it. So I was always confused with CQRS because for me it was obvious. I mean, there's a data store. I can write to it in one way and read from it another way. And by the way, I think it was around 2000. So the problem was we used CMP, Container Managed Persistence, and the entity beans back then were not very capable. So we used them for storing, and we used data access objects, DAOs, to read. So this was like 26 years ago. We used, CQRS. Of course, there's a problem because if the CMPs are caching, you have to be careful with the consistency. But and since then, I just thought, okay, we can do this. And then, I got lots of questions. What's my opinion to CQRS? I say, okay, this is one way of do it, but there's nothing special in it, right? Or do you see something very special in CQRS? I would say, if you will build an app, and we have a data store nowadays, and you will tell me, okay, we have this class which writes, and this class which reads, and this which writes uses JPA, and which reads JDBC, I would say, okay, we have to be just careful with caching, but I mean, done, right? I would never call it CQRS.
Yeah, I think it depends on how strict you want to go into the definitions here, but there's also a pattern called CQS, which is because I think that, and this is how I understand it. Because I think the main, like you described here, to me personally, I think that the main reason why I kind of like this CQS or CQRS thing is that you can have a different model or a different code, or like you say, a different way to query your data. That's to me, that's the most important thing, because I many times I don't.
This is always the case, right? If you have large application, it's always
it's not always the case. I mean, the difference with CQRS is that you have a different, like for example, if you have one like table for writes, and you have another table that is for reads, like you don't read from the same table, you like replicate the data, but not only replicate the data, you kind of replicate the data and change it somehow so that it better fits your queries, then it's CQRS. Otherwise, it's just CQS.
Okay, do you mean if I would use... okay, this is even weirder, because what it would mean is, in some projects, the same timeline, there were projects which were not allowed to interact with the tables directly, and they used materialized views because of reasons. So this was like the decision because they're more flexible. So it would mean if I have from Java exactly the same Java object at JPA, and I'm using from the reading from materialized view and writing to another table, it would be from Java, identical code. I would be in CQRS camp already by definition. So this is, in the database, it's very common that you have a table and you have a view, and the view can be completely different. And this is usually defined like, create view from select or whatever the syntax is, and you have a completely different representation of the table. And we would be already in the CQRS camp then, right?
Yeah, maybe. I don't want to swear on that. I'm not that into the weeds on the exact definition. So
no, it doesn't have to. But the question is, we can have a very strict definitions, but in the end of the day, we have to accomplish something in the real world, right? So this is more. This is not like academia.
Yeah. No. And I agree. I mean, that's for me is the most important thing. Obviously, I mean, I want to get things done, but I want to do it preferably in a way that has less coupling, and I prefer to do it in a nice way that you can continue building on the project a long time. That's my goal, and I don't want to overcomplicate things. I want to be pragmatic. That's important to me. But I just want to say one more thing as well, because the other side of event sourcing is subscriptions. So typically, if you have like a CQRS application, what you do is not to go into the event store or the database and replicate tables and things like that. What you typically do is to subscribe to events, and then have like an event subscriber.
In CQRS or in event sourcing? In event sourcing, yes. In CQRS, not necessary, right?
No, exactly. But it usually goes hand in hand with event sourcing. So after the events have been persisted to the database, then you have some sort of subscription mechanism, so you can subscribe to new events, and you typically use these subscriptions to create maybe like views and things like that from the events that come.
But from my pragmatic point of view is the event sourcing, the events itself are already persistent. And if you store them to a database, it's a cache which can be always reconstructed from this stream of events, right? So the database itself is just a cache, is more convenient, and you can have as many databases as you like. So indeed, in fact, what we did actually in projects is we had, for instance, OpenSearch or Elasticsearch and Postgres databases. There were two views to the same event stream. And because it was convenient for us, we needed and we could reconstruct the database at any point in time, actually.
Yes, and that's one of the benefits as well with event sourcing.
But for me, for event sourcing, is this like natural? If we move in real world, event sourcing happens. Right, because we see event, and we ignore the events or react as humans to events. And if you write the events to a store, it's optimization, because you lose the entire history. You only have the final state, and you don't know how it happened.
Yeah, unless you have event sourcing. Yes.
Yeah, and the cool story, an absolute use case why we need event sourcing more often right now, is audits. So in a projects, we move away from Postgres to Kafka streams, because what they wanted to have is the entire history for audit purposes. This was a highly secure system, and what we said, okay, we can write to Postgres and then install CDC, and then we have the events afterwards. But it turned out it is easier to design the entire system with Kafka streams. And it was, so we had the audits. We could write everything to Postgres or whatever database, but we didn't have to, right? So this was the interesting part.
Yeah,
So what
I
you're
think
explaining to me is, for me,
there's
this is natural. There's no downside so far, so I cannot see any.
I just want to emphasize something here because auditing, you can actually do auditing without event sourcing. I mean, if you have, there's like a Hibernate project for this. I don't remember what it's called, maybe auditing or something. And
No,
there
it
are
was.
lots.
It was built. So it was a separate project.
Yeah.
Created by Software Mill, by an excellent company, and then was incorporated to Hibernate afterwards.
Uh-huh.
And now it's a part of Hibernate. And it was Enverse or something, wasn't?
I think that's. I don't remember, but the point is that this is not really the same thing. I mean, you can have auditing without event sourcing. I mean, the really crucial thing with event sourcing are the domain events. It is that you actually capture.
Enverse was the name. Enverse.
Okay. Okay. It is that
but
yeah.
in Enverse, it was similar to event sourcing, but is not. And no, there is no domain aspects, but it is basically you get a key, and you see the history for the key. You know what happened with the object, and if the object is a domain object, then we have a kind of event sourcing, right? I mean, because
I wouldn't. I wouldn't say that because
that's interesting. So why not?
Yeah, no, because there's a difference between auditing. I mean, imagine this: like you have like a user, and the user has an address, and with auditing, if the address change, I mean, you can get like you can see in the audit that okay, the address changed from this value to that value, and that may be fine. That may be all you need, and there is nothing wrong with that. But what event sourcing can give you is why the address changed. So there you would have like an event that says, okay, so person moved, for example, or user moved to a different location. That's the event, and maybe and the address can also change because I don't know, it was corrected by customer service or something like that. And that thing can be important to the business. So it's not only that you capture that some data has changed; it's the intent of the change that you also capture, and this is the really important thing. As well, that you base your decisions that you do on the history. So in this example, when we have auditing with just a table, you typically just like you read the table. You don't read the full audit to make the decision. Instead, you read like a snapshot to make the decision. With event sourcing, you want to well, if you want to be more advanced, you can use snapshots stuff as well. But typically, you just want to read the full history. And always take the decision on the history. Yeah.
But according to Martin Fowler, I think it's called transaction script, and the transaction script is like the not that rich. So you have a command objects, and with the command object you can reconstruct the domain object. And I think auditing would be a form of transaction script, right? It's not like the nice way. It's just a very technical way of event sourcing.
I still wouldn't call that event sourcing.
Okay.
It's something else.
Interesting, but I know what you mean is because if you have just the domain object is Hibernate, the logic is somewhere else, and if you just observe the state of the domain objects, the information gets lost, right? So this is why it is not the puristic. You only see that the object changed, and who changed that, but not why. The why is not there. And
no, exactly, and of course you can work around that. I mean, you can have like a different column that says
it's
like
interesting distinction. It's an interesting distinction. And in your case, the domain objects contain more information because this is the why. So the domain event, contain more information because the why is there, right?
Exactly. So what you typically do is that you get the list of the entire history of what has happened to this like domain object. And then you fold it like a fold left in functional programming, or just like a for loop. You like transform this list into some state, because it's usually easier to reason about like a state, the current state. But you always use the stored events to reconstruct the state. And then you use the state like to make a decision. Can we do this? Can we like process this order, or can we, I don't know, change this to this, for example.
Since Java 24 is fold in Java, we have.
Oh, really?
Yeah.
Oh, okay. It's true. There's a sequential stream, right, or something like that.
It's called
it's easier.
gatherers, and there's a method called
gatherers.
fold.
Yes. Yeah. Right.
Yes.
Right. Yeah. But you have in Java. You've had in Java for a long time. But it's kind of like before you could do like collect, but it was a bit on the stream.
Yeah.
But I don't know when that arrived. But you have like something called a sequential stream or something like that. Then I think there's a reduce function that is easier to use.
Maybe, but in gatherers there's built-in fold and scan.
That's great. Yeah. Exactly. So it's usually called fold left in other languages.
Okay.
But a for loop would work just as fine. So and then the important thing is that your domain object, it returns new events. It returns the new decisions that it has taken as events, if everything is fine. And then you store these events in your event store, or append them to the stream. Yeah.
What we did in Kafka is we had low-level events. Let's imagine, so always my example, we fitness tracker. We just GPS coordinates as the one event where someone goes running or whatever. And then from these low-level events, we created richer events. And so they were just, we had one event store or queue or stream and another one. So this was like a huge copy mechanism. And the highest event was was what we actually consumed. And if you had microservices, you could subscribe to whatever stream you liked, and they were completely decoupled. And if a microservice was interested, or consumer was subscribed to the GPS coordinates event, or just received GPS coordinates, but you could also subscribe to the city or whatever places, locations stream, and you got the enriched events. So there was a cascade of events. And this worked actually surprisingly well. It is in some enterprises is not well received, interestingly, because they have pay the storage costs. And this is when they start to optimize, because if you are in serverless, you are paying per partition in Kafka. And if you are in on cloud, you have to pay for the storage. And I think the best event sourcing is infinite, right? So you have the entire history in place, and you can always react. You don't have to, but it should be the optimum.
Yeah. Oh, there are a lot of things to unpack here. I think.
Hopefully, we'll talk about your framework as well, because right now it's just interesting things.
But this is very interesting. So I'm fine with continue talking about this if you like. But well, first of all, I don't think, and I think this still is true, but at least historically, I don't follow Kafka all that closely, but at least historically, Kafka has it shouldn't really be used as an event store. And I think it has to do with like how it maintains like partitions, and also I think that what an event store must guarantee is that a stream is consistent, and a stream, this is like the list of events for a particular business object. This must be consistent. So if two threads, if you like, tries to write to the same stream at the same time, it must guarantee that only one succeeds at the same time, like some kind of optimistic locking and things like that. I'm not a Kafka user myself, so I'm not really into the weeds there. But
it will work in Kafka because it is depending on the key, and the key is mapped usually to a partition, and then it's given. So if two writes, this is consistent.
Yeah. Okay. Yeah. Maybe you know better than me, but it's like one of these things that you often hear when you come into the event sourcing community, and many people try to use Kafka, but it's very common that you hear that Kafka is not really built for event sourcing. I think it may also have to do with the things that you just said, like with compaction and stuff like that, that comes in from time to time with Kafka, because with event sourcing you want to you don't necessarily want to keep all events. This depends, and this is another area that we can go into if you like. But you don't want to have like random compaction, because then you don't have event sourcing.
No, Kafka has no random compaction.
No, not random. That was not. I understand it's not random, but you cannot like lose you can't lose events unless you
No, you
you
cannot
are
lose
in
events.
the
Yeah, exactly. There's in Kafka you have to say I don't like it, sort of like tombstone event which deletes everything
yeah
afterwards. But
yeah
what Kafka does since recent days is they can have second level storage. So if you
yeah
like,
yeah
they can. Yeah. So I mean,
yeah okay
this is not like technical problem. It's more like organizational or political because one department just runs the entire Kafka thing, and they are not capable of do this. So they just have a basic Kafka support, and everyone has to pay for it. So this is actually said as it is, but this is like this. But I just said I found strange reasons in. But back to
But can I
your.
say one thing? But can I say one thing about this, like tombstoning and like what events you want to keep and stuff like that? Because that is actually quite interesting as well. Because I mean, also in event sourcing, there is a concept called snapshotting,
Mhm,
which I guess can be very similar to this tombstoning kind of thing, or at least it is a way that you can, like, if you have long streams, which you shouldn't have,
mhm,
like a long list of events, you should try to keep that short. But if you for some reason have that, you can use like a technical construct, like a snapshot, where you do store like some state at a particular time, and then
mhm,
you read that, and then you only read events after you've taken a snapshot.
mhm,
And that can be a bit tricky to from an implementation point of view to get that working. But what you typically, I mean, I think that you should do is to instead see in your business there may be like certain cases where it's natural for you to, as it's referred to, close the books. For example, you may have a cash registry, like maybe
mhm.
it's natural for this cash registry to reset like every night, for example,
Yeah,
or in the case of
yeah.
accounting, maybe every year you can like
Mhm,
maybe you copy the events to some other long term storage somewhere, and you kind of start over
yeah.
the next year, and that
So
is a good way, I think.
what you could
Yeah.
do with Kafka is you can create on-demand new streams or not new topics. The name is topic, so on demand. So
Mm,
there's no problem.
mm,
There is and I actually did it not in Kafka but DynamoDB, which is a
mm,
database, but it can also you can subscribe to events. It's called DynamoDB streams. So
mm,
what happened is I created on-demand new tables with a specific date for a new day.
mm,
Because
mm,
audit purposes and also for query,
yeah.
everything was simpler with that. So you can
Mm.
absolutely do this, right?
Yeah, yeah, you can do that, but I would still be I would be a bit cautious. I would read up on this Kafka and event sourcing if I were to
Yeah,
pick Kafka for
I'm
event
just
sourcing.
curious what because
Yeah,
for me, like the Kafka was the classic event sourcing stuff. Even the CDC change data capture and so forth was like, but
uh, yeah. My experience is that the word on the street is that it's actually the other way around. Kafka has at least historically not been good for event sourcing.
and for what then?
It's
How they call Kafka for what? So
No,
what?
but there's a different. Kafka is excellent for event-driven architecture, but that's a different thing. Like if
Mhm.
you want to like integrate between different services, and you want some events to be available to other systems, then Kafka is great. But that's a
Oh,
different
this we
thing.
never used for that. So what Kafka has, there's
Mm,
the low level Kafka, which is boring. This is what you're describing with bytes. Then it's Kafka
mm,
streams, and where you can subscribe
yeah,
to one stream and join streams and just all
yeah,
the
that's
entire semantics.
yeah,
And then is
yeah,
a KSQL, and what you can even do then, you have a stream. You can how to call it, materialize the stream as a
yeah,
table even.
yeah,
So
yeah.
all the constructs are there. I don't know how to call it, but it is very usable, and we do it in projects. So maybe it's not puristic event sourcing, but it sounds very similar what you are describing, if not identical.
No, yeah, what I'm maybe it is in what I'm trying to describe is the difference between event sourcing and event-driven architecture, which is not really the same thing. Because
Hmm.
event sourcing is this is like we just discussed, like you have your events and they are persisted in some
Yeah,
data store, and you
yeah,
always base your new decisions on the previous events. That's what event
exactly.
sourcing is. And
Yeah.
but then if you then it's a different thing. Like in many event store systems, you have your event store, you store your events in the event
Hmm.
store, then you have like a subscription, And then you get new events to this subscription, and then you can publish these events after they have been written to the event store to something like RabbitMQ or Kafka for other services to consume and do whatever they want to do with them, kick off a new process or do something else. And that's kind of the difference.
What I'm consulting is I help a startup, and what they are building is like shift management or role management for, let's say, airport or something like this, right? So they have roles would have match stations and so forth. It's a crazy complex system. And how this works is that whatever in the system happens is event, and there is no central database. And all the rules are encoded in transition, or not transition, how to call it, in not transition. If we create for one event another event, right? So there's like subscriber to event, like a processor transceiver, we call it. So we receive an event and then enrich the event and store it in another topic, and someone wakes up and does something, and at the end we have this what we want to do. And as an UI, you can subscribe to whatever, and you get very reactive point of view. And how you describe such a system? So the entire logic of the system is in events.
Yeah, no, that can be, and that's perfectly valid. But I wouldn't call it event sourcing. It's event-driven architecture.
So maybe it's not event sourcing, but this is implemented with Kafka. And,
but event sourcing has nothing to do with technology. It's, I mean, you use technology.
But I was curious what it was, because it works. How to call our system event-driven was less than this, because event-driven would be, we do it all the time in the cloud, because whatever in cloud happens in event. So we subscribe to S3, to DynamoDB, to whatever. I have to subscribe to the event. So I react to the events, and this is for me event-driven. But they are technical events. And in this startup projects, there were highly domain events. So we spent a lot of time, designing the events and talking about them, and this was really domain. So if you look at the domain event there, it was almost like back then it was JPA entity, and now with Postgres, and now it is an event. So there is no JPA entity involved anymore.
Yeah, and that's perfectly fine. But it's not event sourcing, strictly speaking. It's something else. It's event-driven.
So how? Let's say
but I also want to mention one last thing that is really important, because you mentioned enrichment here. You got like small events, and then you publish some larger events to other systems, and I think that is really smart. I mean, what you typically want to do in an event-sourced application as well is that you probably don't want to take it. This is not the best example, maybe, but let's take an order, for example. So you have like some ordering system, and you can change stuff in the order. You can maybe there was when you created the order afterwards, maybe you needed to change some correct some order line or something. That is an event because you made a change, but that small change may not be something that other systems should care about necessarily. So what you typically want to publish to other system, it's because what you store in the event store is something that I refer to as domain events. This is like the source of truth. But what you publish to other systems, that is another kind of event. This is an integration event. Well, and the purpose of the integration event is to be larger, so that the receivers don't have to listen to all of these like really small different kind of events to build up their own state or to figure out what to do. And that is really important, because otherwise you get like coupling to the source service that has event sourcing, because these events you want to be able to change them. This is like a business problem that you're working on. You need to be able to evolve them. But the domain event, this is like a published contract, a public contract that other services can use. So you have to maintain backward compatibility and stuff like that for the other services. So that's an important distinction.
In our case, it is actually in production. Is the systems? Oh, the system is writing to the event store, and that's basically it. So this is like, and whether someone listen or not listen, we don't care at all. So this is like the events are in the store. And if someone would like to listen to the events, so the consumer will subscribe, not necessary to this store. Usually you can have another stream, which and we can have mapping, event mapping. I don't know how to call it. So enrichment. And they can enrich, the events however they like, and they listen to their own streams or not. So this is their decision. But there was no notion of subscribing or pushing. So the event store doesn't know any other systems. And the systems can decide whether they would like to subscribe to existing streams or topics or create a new ones. And if you create a new one, it looks like Java streams in Kafka. So you have on DSL and you can say, okay, read this and do whatever. And this worked well, actually.
Yeah.
But this was not intentionally event sourcing. I was just curious what it actually is, what we built. But it works well.
Sure. And that's like, I understand. I think everything you're saying. But one problem that may arise here is that the ownership of data. If you have like different teams, you may have one team that works with the ordering and another with shipment, for example. Then these teams should be able to work autonomously. They shouldn't have to like sync all over the place. So if the ordering team needs to change something or introduce something new, or maybe do something like some backward incompatible changes, they should be able to do so without like having a lot of meetings and coordinating with different teams. And
you're right.
Like that. So
as I said, it's just,
and that can be the problem if you just like push everything.
One team.
Yeah,
and in larger projects, you can use the schema for the events. So but what I would like to hear is actually your framework. Because right now is like I just misused to find out what we actually built.
No, I love to talk about this. It's really great. This is the most this is the most important thing that we're talking about now. The stuff that I've built, that is it's just one way to do things in Java and Kotlin. So No, but so what it does is there are a lot of different modules. We are using MongoDB quite a lot at work. So I've written 4 different MongoDB implementations for both like vanilla blocking MongoDB and reactive version with Product Reactor, and then like a normal blocking Spring version. And is that it? Yeah, maybe there's some. No, and only 3 for MongoDB and 1 in-memory implementation. And people have, some people have started working on other implementations, but it can be quite tricky when it comes to these subscriptions that I talked about before. So people have made good contributions, but maybe they have not taken them all the way. So currently it works with MongoDB. And as I said, it's based on CloudEvents, but there is a distinction here, and because what I wanted to achieve here is that you should be able to design your domain model in any way you like. You don't need like some annotations and stuff like that from your current library. You can decide you can implement them any way you like, as long as you have something that can take the current state, which is the list of events that is stored in the event store. So as long as you have some sort of function or something that can take events and return new events that should be stored in the event stream, then you can design your domain model in any way you like with Occurrent. Because then you have an explicit translation layer, because what's actually stored in MongoDB are cloud events that we mentioned briefly before. The events are serialized as cloud events. But you are responsible yourself, or you can use some of the built-in stuff that exists. There are several different implementations that I've written to map from your domain events into cloud events before they are stored. But there's a strict separation between what you use in your domain model and what's actually stored in the data store. And yeah, I really like that personally. And I think it gives some really nice benefits. Yeah. And then yeah, Occurrent, it's event store, but also these like subscriptions. You can subscribe to events after they have been written to the event store in a like how do you say, in a durable way. So it is guaranteed that your subscribers will get all events, even if you crash. Like after maybe you have written your event to the stream and you crash, then you will still get the subscribers will still be called with the events once the application comes up again, and things like that. Yeah.
Okay, let's say I have a class, a domain, a class Java record or class workshop registration, and I would like to capture all like registered, confirmed, let's say, just to have more states, then paid, delivered, and certificate sent, let's say.
Yeah.
How this would work with Occurrent? So I have a Java class, what I should do?
Yeah, you can decide yourself what you want to do.
I'm
but typically,
what
all
the
I do,
states have to be stored in somewhere.
Yeah, sure. No, but what you do or what you can do, and what I typically do is that I just create.
Exactly.
What I do is to create a class. Now, what did you call it? Workshop or something?
Workshop, yeah. Workshop.
Yeah. So I create a class workshop, and then I have static methods actually for each use case. And why do I have it static? Is because I don't maintain any global state in this decision thing. So it's just static methods. Yeah, and it takes as input. It takes the list of events. This is like the prior events that you have. And then it can just take the other things. What do you need to make this decision? I don't know. It takes a workshop. Is it like a student? Maybe you pass a student and you pass I don't know, something else that you need in order to take the decision, and then you return new events. That's it.
You know what it is? You know Redux?
Yeah.
Very similar.
Yeah, it's very. Yeah, it's there are similar things. Yes. Yeah.
It's exactly the same. So what you are doing is you are creating an event, and is actually your job to create a new. You have to merge your
exactly.
event.
Exactly. Yes. So that's your
then
job.
It would be Java record. Actually, would be better. Java record with the current state, and the static method would help you to merge the state, right? So.
No. Yes and no. It depends. Like usually, I mean, what I typically do is just to take the list of events, and the first thing I do, if I don't want to do it, then you can go more fancy from here and build like, and maybe you want to do that. You can build like more higher level constructs, but in the most basic sense, you just take the list of prior events. Yeah. And then what you do, the first thing you do is that you like do this full left thing. It's also called evolve. You evolve it into some state, but this state can be private inside your. Maybe you like, or you can like have a class outside this workshop class if you like, but you can have like an internal state, because this state is only used for the decision. You don't need to expose it ever.
But the record is immutable. It means the first state
sure, but I don't mean that. I know, but what I'm just saying is that the workshop class itself doesn't have to be a record. That is just like a bunch of static methods, and internally you can use or maybe an interface.
Java interface with just static methods, and but let's make it concrete. So someone registers to a workshop, Duke Java registers to a workshop. So there's the first event, like registered.
Yeah,
with date,
exactly.
Registered and address and all the data, right?
Yeah, and all the data that is relevant to that. Sorry,
there's an empty list because there are no prior events. So exactly. There's the first event. So what will happen? A static method register will return a list with one event.
Exactly.
And the structure of the event, this would be is it provided? No structure. The event type is provided by your framework, or should I do this? Okay.
No, it's and this is the crucial thing. What I wanted to achieve with Occurrent, you can No, you have your whatever you like. You don't have to think about serialization and nothing at this point. You can decide whatever you want to use here as events. Typically, what I do
Java
is to
record.
have like
This would be Java record,
yeah,
right? Event would be Java record.
typically,
actually.
but not necessarily. I mean, you can do whatever you like, but what I do is that I usually have like a sealed interface that says like, oh, this is like a workshop event, and then I have like record implementations exactly
which is
for each workshop event.
Yeah, this is fits perfectly. Mm-hmm.
Yeah, so this is what I typically do. But you don't have to think about
the proper way to do it. So this is advanced.
Yeah, I don't think it's advanced, but I think it's how you should do it, perhaps. But
it
is
somehow advanced because it's only possible since sealed classes are available.
Yeah, right? Sure. But if you don't have sealed interfaces, you can use a regular interface if you like, or don't use an interface at all. I mean, you can just have records or classes with getters and setters if you like.
Sealed interface and records is the right thing to do, I guess. Because
I think so.
Mm-hmm.
Yeah. Mm-hmm. Yeah.
And the second is interesting. The second event. So the second event is like paid, right? Or no, not paid. Invoice sent. Let's say to have more events. So invoice sent. So I have the first one, the second one, and what I do in fold, just create two, because.
Yeah. No. In the fold, this is where you take your prior events, those that have already been stored. So in this example now, we only have one. We only have registered.
Yeah.
So what you typically do then, this fold kind of thing, it produces a record usually, which is the state of your application for this decision logic that you want to do. And I typically model this as a state machine. So you have typically I have like, but it depends on the case. Sometimes you don't need to do this because it's too complex. But many times I think it is very good. And it is that you have like a sealed interface here as well. You call it maybe like, I don't know, if you have a like workshop state or something, but you can have the state can be in different records. So you have different states. Like now workshop is registered. So you will fold the events into a workshop registered record. But if you were in a different state, you would get like workshop, I don't know. What
so the fold is basically like reduction, right? So what you would like to achieve is, which is the current state plus the event is next state. This is what we need.
Yeah, exactly. Or in even simpler ways, you want to convert your events into the current state, exactly, so that you can make a decision on this state and the new things that comes in. Because maybe now you want to register a participant or something. Maybe that's what you want to do as a next step. So maybe let's say another thing. Maybe the first event was like workshop created or something. You have to the workshop needs to have been created. Now you can add participants. Maybe that's the second step.
Yeah. What I thought is about a single registration for one participant, but we can have workshop itself. So it's like creation with description, whatever, and then we can say max attendees is like 10.
Exactly.
And the next step is so then it's more interesting because then we get a new registration and we have to reduce the current registration count, right?
Yeah.
Or increase to 1. Yeah. And this would happen in fold because we have the state and we have the event and we have to decide what happens there.
No, that's a little bit. No, in fold you don't decide anything. The only thing you do in the fold is to build up the current state. That's the only thing you do. Then you make a decision.
But in order to build up the current state, I have at least increased the number of.
Oh yeah. Sure. Yeah, based on the data from the events. Yes.
Yeah, exactly. And this is why you need multiple static methods.
No, no. Maybe
why not? Because we have one static method is called register. The other one would be.
Oh yes. But you have like one static method per thing you would like to do.
Exactly.
Yeah, maybe okay. I misunderstood you. Yes.
And the static methods have business meanings usually.
Yes.
They cause state transitions, and they would be like registration as a higher level use cases, maybe even.
Yeah, exactly.
It's like the
facade. That's how I do it. So in Kotlin, I mean, one way to do it here, you don't need a class in Kotlin. You can just put the functions or these like static methods equivalents in Kotlin. You can just put them in a in a namespace directly or in a package directly. You don't need a class.
Mhm.
So in this case, now Java doesn't support that, but if Java would have supported that, you don't even need a class. You just need
you
methods.
can have an interface. Exactly. This is the same. This is like procedure.
Yeah,
Okay.
yeah, not quite maybe, but yeah, but
why not? I mean, you have interface static methods. You can do whatever you like.
yes, but it's not really the same. I mean, interface is still like then you need an interface, like you need a file on
you're
your
right.
yeah. So that's not you don't really need that in Kotlin and some other.
You need some file, but
functional
because you have to define the
true.
method.
Yeah,
so in Java
true.
will be one
But
line
you don't,
more. This is what you don't like.
Yeah. No,
this
I'm not saying
interface,
that I'm not saying that I don't like it. I'm just saying that that's an option. I actually prefer even in but I actually prefer even in Kotlin to have it's called an object in Kotlin for exactly this case. So it's like a singleton.
So the Kotlin is actually not as bad as people say, right? So it's actually you can do useful stuff in Kotlin even.
Yeah, Kotlin is quite nice. No, so no, I kind of like to have them grouped personally, but yeah, if you like, what I'm trying to emphasize is that since you don't maintain any state in this workshop class, you don't actually like you can just have the functions without outside a class
because
since they are
the
kind of pure.
workshop class should be called maybe workshops, and this is like this only comprises the static methods.
Yeah,
and the state modifications are on domain objects, and they are separate, right?
State modifications are new events that you return.
But in this system, I could still keep my domain objects because if they're easier, I can have the current state captured as domain objects, right? The current state.
Yeah. So what I mean here, it depends on what you mean by domain object. But yeah, sure, it is what you can do. And now maybe this is the next level. Maybe you want to store the state as well. I mean, you could do that. So the method you could change the method to return not only a list of new events. You can change the method to return a list of new events and the updated state, and you can store both if you like. If you can store them in the same transaction, that's really important. Or you can decide that maybe you don't want to use event sourcing. Maybe you want to I want to store the state, and then just publish the events. You can do that.
I mean, if I have already the mechanism in place, is everything fine. So I have this. I know my current state. But if I know my current state, it would be nice to have Java records which have the state, and I can work with calling methods and they don't have to change the state. They can be derived attributes like more calculations, and this domain objects would represent the current state. If the system dies, it can be always reconstructed, and I get another set of Java objects.
Yes.
Right, this is what I mean. It's like the cache. This would represent, my database in Kafka, something which I work with, but I don't care about persistence.
If I understand you correctly, I mean, or let me rephrase that. The important thing with event sourcing is that you use the events, not the. What's stored is in event sourcing. Strict event sourcing is only the events.
Yes.
And then you get events, you fold them into whatever model you like, record or something, and then you typically base your decision on this record, and then you return new events. You don't store typically this record that you have. That is only for taking decision.
Maybe I have a visual example for it, because
I have examples on the website as well, so you can check out exactly how it looks.
I will put it in show notes. This is Occurrent. There are lots of examples.
Yeah, I think so. But also in the documentation, and there are lots of examples in the GitHub repository as well.
I have not best practices. The only practice which are working is if you use Redux in front end, it's not Java nothing. It's just web components. What people sometimes do is they pick a table component, and this component has an own state. And this is completely wrong, because now the state is stored twice in the Redux store and in the component, and you get lots of trouble. So it means what you do is the table is just a view. And if you modify state of the table, it modifies the Redux store. The Redux store updates, or not updates. It says I changed, And all the listeners who are interested in the change will update themselves, also the table. And this is what you described in Java is less visual, but I'm not allowed to maintain state in the objects. Every change of this is almost CQRS actually. If you change the state in the object, it should flow through the event store, but you can read through the Java object, and it has a view to the event store, right? So this is almost CQRS actually, a small use case of CQRS.
Yeah, maybe. But there's actually a lot of stuff there to talk about if we want to go into the specifics.
No,
but
I have to reinvite you back because we had we spent, and we will talk a little bit about more about Occurrent, I think.
Yeah.
And for what I will do the first time as preparation to the podcast to learn about the wording, because I was not specific enough. And this was why we misunderstood each other. So at least you know the domain concept, so the definitions, and then we can be more efficient in the communication. So where people can find you.
I think this discussion, but I want to say, I think this discussion is really good because there is a lot of confusion around event sourcing, and the naming, it can matter.
Sure, it has to.
So I think it's really good.
The discussion, I have I have the impression we are 10% done, but the next time we will talk about this more deeply, and I'm interested in the Occurrent framework, and well, people can find you, and where can they find Occurrent? So exactly.
They can find me. Where can they find me? On Twitter. I don't write much, but I hang around. So it's my first and last name concatenated, Johan Haneby, in one word, I think. Other than that, Occurrent you can find at occurrent.org is the website.
Okay.
And you can find the GitHub repository and everything from there. I mean, Occurrent, when did I start that? I think it was in 2020. It doesn't feel that long ago. It's still the project that I really enjoy working on, and I still have lots of ideas that I want to implement and do. So I find that really really fun to work with still.
Yeah, and we will explore your ideas next time.
Yeah, thanks.
Thank you a lot.
Thank you.